if L1 is R is 2, 7 minus 3 plus lambda minus 3 minus 4, 5, determine whether each of the following lines are either parallel, perpendicular or skew compared with L1. So what we've got to do is compare this line with this line and determine whether it's either parallel, perpendicular or skew, and the same for B and the same for C. Okay, so if we write out the two lines, now what you've got to remember, these are vector equation of the line, so this vector here means a point on the line, and this is called the directional vector of the line, same here. So if we, and it's the directional vector that we really need to look at here. So if we look here and here, so we'll call that D1 and we'll call that D2, we can see that if I was to multiply that by minus 2, I get 6, and if I multiply that by minus 2, I would get 8. If I multiply that by minus 2, I will get minus 10. So what we can see is that 6, 8 minus 10 is minus 2 times minus 3 minus 4, 5, i.e. D2 is k times D1, or we could do D1 is equal to k times D2, but k would be a fraction that way round. And then this vector is a scalar multiple of the other, and therefore the two vectors are parallel to each other, and therefore the two lines are parallel. Now we can look at that using this GeoGebra applet. Okay, so here we have the original line. Okay, so I need to just put the values correct though first before I do that. So I need to change D to D1 to 6. So you could, the GeoGebra applet I will put in the notes of the video. D1 I will put at 8, D2 at 8, sorry, and D3 at minus 10. Okay, and then we can see very clearly, and we move it around a bit, that the two lines are in fact parallel. The point A here is the point 1, 4, 4. Okay, so this is the case where we have parallel lines. Okay, so let's now look at the second case. So in the second case, R1 is still the same line, but R2 is the same point, but the directional vector becomes 2, 1, 2. Again, we look at the directional vectors. First, we're going to check to see whether they're parallel, and we can very clearly see that D2 is not equal to some multiple of D1. Therefore, we immediately would say they're not parallel. Now, if we want to check that they were perpendicular to each other, all we need to do is find the dot product of those two vectors, and if it's equal to 0, then the two lines are parallel. So we need to do minus 3 times 2, minus 4 times 1, and we need to add it to that, and then we need to add to it 5 times 2. So that gives me minus 6, minus 4, plus 10, and we can very easily see that we got 0. So this means that the two lines are perpendicular to each other. And we can look at that, use this GeoGebra applet. Okay, so just need to change the parameters here to 2, D1 being 2, D2 being 1, and D3 being 2. Okay, and there we can see here they intersect each other at the intercept at this point. We could find the point of intersection, and we could find that the two lines are in fact perpendicular to each other. If we move this around, we can see that very easily. Again, I'll tell you, the GeoGebra applet will be in the notes of the video. Okay, in the last case, possibly we might have skew lines, we will realise by now, but let's have a look. Right, so we've got same point again, but different directional vector. So first of all, we'll check to see if they're parallel. So looking at the directional vectors, we will see that in fact D2 is not a multiple of D1, so not parallel, and also that if we did D1 dot D2, it's not equal to 0, therefore not perpendicular. So we can either now consider whether the lines just intersect at any angle other than 90 degrees, or that they are what's known as skew lines. Okay, so first of all then, we'll just check to see whether they intersect. Okay, so this is going to require a little bit of work. So if you check to see if the lines intersect, you need to take the x component of one, which is 2 minus 3 lambda, and put it equal to the x component of the other one, which is 1 plus 3 mu. That gives minus 3 lambda. We take that over here, we get minus 3 mu. Take the 2 over here, we're going to get minus 1. Just be careful when you do that, and we'll check the y component. So 7 minus 4 lambda is equal to 4 plus mu. And again, we'll just check everything out here. So we're going to have minus 4 lambda minus mu is equal to minus 3. Just make sure you do that carefully, and we will now solve these simultaneously. Now, in an exam, maybe you use your simultaneous equation solver. Okay, I'm just going to do it algebraically. So, keep the first one the same. We're going to multiply the second one by minus 3, so it'll become 12 plus 3 mu is equal to 9. And then I'm going to add these two equations. So 12 minus 3 gives 9 lambda. Nothing from here, and minus 1 plus 8 gives me 8. That means that lambda is 8 over 9. Substitute that into 1 or 2. So we've got minus 3 times 8 over 9 minus 3 mu is equal to minus 1. The 9 will cancel with that 3, and then I'm going to have minus 3 mu is minus 1 plus 8 over 3, which gives me 5 over 3, and then divide by minus 3, I'm going to get that mu is minus 5 over 9. Okay, if it intersects, then it will work for z as well. So this is what you need to do. You need to check for z. So z here is minus 3 plus 5 lambda, so it's going to be minus 3 plus 5 times 8 over 9. Use the fraction button on your calculator, and that'll give you 13 over 9. And then for the other one, it's 4 plus 2 mu. So it's going to be 4, and make sure you put in mu rather than lambda. So that is 4 plus 2 times minus 5 over 9. Again, on my calculator, I've got 26 over 9. Well, 13 over 9 is not equal to 36 over 9. Therefore, the lines do not intersect. So if they do not intersect, then they are not parallel, not perpendicular, then they are called skew lines. Okay, let's have a look at that. So we'll need to change the parameter of d to, we'll just have to change the top one to being 3 actually. Okay, and what we can see is they look like they intersect from this, but we can see here, in fact, they don't intersect. They, in fact, and they're not parallel to each other, and therefore they are called what's known as skew lines. Okay, you can see very clearly here they don't intercept each other, and it's a bit harder to see, but they're not parallel to each other. Okay, so this GeoGebra app I will put in the notes of the video. There are other values of this. Obviously, there are a lot of values of this which will give skew lines, but there are actually other values which will of the directional vector which will give perpendicular and parallel lines. I'll let you think about that. Okay, I hope you've understood. I hope the GeoGebra app helped, and I thank you very much for watching.